My dear students, good morning all. Today I am going to discuss about types of oscillations. So already in our previous videos I have discussed about what is wave, what is oscillation, simple harmonic motion, types of simple harmonic motion. So but today I am going to discuss about types of oscillations. So these are the three types. Number one is free oscillation, number two damped oscillation, and number three forced oscillations. You can see here. So types of oscillations. These types of oscillations are divided into three types. Three types. So first one you can see here on the screen. So this is definition. What is free oscillation? Free oscillation. Every particle, every body has its own natural frequency. What is natural frequency? So this is 1 by t. In general, time period t is equal to 2 pi root of L by g. So this is length. This is the acceleration due to the gravity. So here we can write this is 1 by 2 pi under root of g by L. So this is natural frequency. A body or particle which is oscillating with its own natural frequency phenomena is called free oscillations. Free oscillations. So what is damped oscillation? What is damped oscillation? If the time period increases, the displacement of oscillatory particle or amplitude of oscillatory particle decreases with respect to frictional force phenomena is called damped oscillations. So I am giving the definition with the graph. So take an x-axis time, on y-axis so displacement x. So this is the, for example, amplitude. So this amplitude value decreases. You can observe here. So time value increases, displacement x value decreases continuously due to under the consider of frictional force phenomena that is called damped oscillations. Damped oscillations. What is forced oscillation? What is the definition of this forced oscillation? I am giving only definitions. So clear discussion, free oscillation. In free oscillations, we will discuss simple oscillator. What is the equation of motion? What is the solution of simple oscillator? What are the characteristics of simple oscillator? What is a simple oscillator? If a body executing simple harmonic motion is called simple oscillator. In our previous class, in our next video, I will discuss about simple oscillator. What is forced oscillator? Third one. What is forced oscillator? If some external periodic force is applied on the body oscillates with the external periodic force phenomena is called forced oscillator. What I am saying? When we are applying some external periodic force on the body vibrates under the influence of external periodic force phenomena is called forced oscillator. These oscillations are called forced oscillations. So types of oscillations, these are three types: free oscillations, damped oscillations, and forced oscillations. I am giving here only definitions. What is free oscillation? If a body vibrating with its own natural frequency phenomena is called free oscillations. Damped oscillations definition: time increases, displacement or amplitude decreases continuously under the influence of frictional force phenomena is called damped oscillations. Forced oscillations. When we are applying some external periodic force on the body The body vibrates under the influence of external periodic force phenomena is called forced oscillator, and these particular oscillations are called forced oscillations. So what is free oscillations? You can see free oscillations. If no dissipative force means air resistance force, frictional force, external force, any other force. If no dissipative force, that particular forces act on oscillating body, then amplitude of the vibration remain constant for infinity time. Such oscillating body is known as ideal harmonic oscillator, and oscillations are called free oscillations. Free oscillations. If there is no dissipative force is acting on the body, that particular body total energy always constant and also amplitude always constant, this type of system is called ideal system. This type of system is called ideal system. This type of oscillator is called ideal oscillator. Ideal oscillator. What I am saying, if no dissipative force acting on the body, then the amplitude of the body vibration remains constant for the infinity time. Such type of oscillating body is known as ideal harmonic oscillator, and the oscillations are called free oscillations. Or free oscillation definition: the oscillations of the body oscillates with its own natural frequency. What is natural frequency? A body vibrates freely at its own frequency. That is called natural frequency. You can observe a body, you can observe on the screen, a body vibrates freely at its own natural frequency. Natural frequency is represented by nu. Nu is equal to 1 by 2 pi under root of G by L. So the oscillations of the body or the vibrations of the particle or the oscillations of an object oscillates with its own natural frequency phenomena is called free oscillations. Or you can observe the definition here: the oscillations of a body oscillates with its own natural frequency when left free to itself. That oscillations are called free oscillations. The natural frequency of free oscillations is given by nu is equal to 1 by 2 pi under root of L by G. So G is the acceleration due to the gravity. Acceleration due to the gravity. So what is small l? Small l is the length. Small l is the length. The frequency will be the same as long as the pendulum does not experience resistance to its motion. Such an oscillator is called ideal oscillator. Such type of system is called ideal system. So what I am saying, there is no dissipative force acting on the body, then the frequency will be the same as long as the pendulum does not experience resistance to its motion. There is no air resistance, there is no frictional force on the body, there is no external periodic force on the body. That means if no dissipative force acting on the body, that particular oscillator is called ideal oscillator. That particular system is called ideal system. The ideal oscillator and ideal system amplitude always constant. If the amplitude of the body, vibrating body, is always constant for infinity time, that particular oscillation is also known as ideal oscillation. That particular system is also known as ideal system. The ideal system, or you observe here, the ideal systems are frictionless and energy is not dissipated away, and hence total mechanical energy and the amplitude remains constant. That is constant. What I am saying, if there is no dissipative force acting on the body, dissipative force means resistance force or frictional force or any external periodic force. There is no frictional force on the body. There is no dissipative force on the body. Then the total mechanical energy means kinetic energy plus potential energy, that is total energy, that is always constant. That mechanical energy, for example, you see total energy here, so total energy is equal to half m omega square a square. So total energy is constant, so we can write total energy is directly proportional to amplitude square. So total energy is constant, amplitude also constant. What I am saying here, you clearly observe. So here total energy, that is total energy is equal to kinetic energy plus potential energy. This is half m omega square a square. So this is constant value. So we can write this is total energy is directly proportional to square of the amplitude. So square of the amplitude, what I am saying here, so this is total energy is always constant. So total energy is always constant means amplitude also always constant. A system which is having total energy is constant and also amplitude is constant, that is ideal system. That oscillator is called ideal oscillator. What I am saying, if the oscillation of a body oscillates with its own natural frequency, phenomena is called free oscillations. A body vibrates freely at its own frequency, that is called natural frequency. You just remember in this natural frequency and free oscillations. A body vibrates freely at its own frequency, phenomena is called natural frequency. The oscillations or vibrations of the body oscillates with its own natural frequency is called free oscillations. The free oscillating body has constant amplitude and constant mechanical energy. That particular system is called ideal system. These oscillations are called ideal oscillations. What I am saying, if there is no dissipative force acting on the body, the body mechanical energy and amplitude remains constant. So this particular oscillator is called ideal oscillator. This system is called ideal system. So what is free oscillation? I am going to close this video asking what is free oscillation. If there is no dissipative force acting on the body vibrates with its own natural frequency, that is free oscillations. So the oscillations of the body oscillates with its own natural frequency, phenomena is called free oscillations. So I am closing this video. Thank you all. Thank you very much.